the Greeks knew the parabola and the hyperbola, as well as the ellipse. By slicing a cone with a plane, they generated curves called conic sections. If the cutting plane is perpendicular to the axis, it cuts out a circle. When the plane is tilted, the circle becomes an ellipse. Tilting it enough for the plane to be parallel to a side of the cone produces a parabola. Tilted farther, the conic section becomes a hyperbola. The ancient Greeks were remarkably skilled in geometric games. By 200 BC, Apollonius earned the title of the Great Geometer for describing such remarkable curves in 8 long volumes. Yet even his pen had barely scratched the surface of the conic sections. In 300 AD, Pappus of Alexandria found another way to describe these curves.
A moving point traces out a conic section if its distance from some fixed point, the focus, has a constant ratio with its distance from some fixed line, the directrix. The ratio of the distances is the eccentricity, E. For the ellipse, this ratio is smaller than 1 and shows how far this focus is off-center. If the two distances are equal, the result is a parabola, a conic section with eccentricity equal to 1. If the point is closer to the directrix, the result is a hyperbola with eccentricity greater than 1.
All 3 conic sections share a common property, and all 3 can be described by a common algebraic equation, an equation that is useful for studying planetary motion. This is the basic formula for describing all the conic sections: the ellipse, the parabola, and the hyperbola. While the ancient Greeks were the first to study conic sections, they never dreamed these curves would influence the shape of things to come. For example, look at the parabola. From the dazzling glare of automobile headlights to the very limited edition 10-meter Caltech telescope, over 1 billion parabolas have entered the marketplace of modern society. Today, among many other things, parabolas are the paths of projectiles, and the heat wave of the future, solar furnaces. Of course, Johannes Kepler never imagined that the hyperbola and the parabola could be found in the heavens.